In software engineering, we are taking chapter number 34, which is project scheduling. What is project scheduling? Project scheduling is the roadmap which will guide all the project activities. Most of the time, we just hear that project failed, this project failed. Now, why there is delay? Why the project failed? Before talking about project scheduling, let us know what are the reasons why the software or any kind of project is delivered late. The first reason is unrealistic, aggressive deadlines. That is, someone from the outside who is not from the software team, maybe in some managerial position. Now he is going to say, okay, you have to do the project in 1.5 years or 2 years. Now this time is forced on the managers and the practitioners, that is the programmers. The second reason may be the requirement of customers keep on changing. And since the project schedule has already been made, it is not reflected on the schedule, or schedule doesn't change with respect to the changing requirement. There may be a case where the honest underestimation of amount of effort or the number of resources to be employed to get the job done is not properly managed or understood or even underestimated. For example, 10 people, only 6 people are being given the job or hired. There are certain risk factors which are predictable or even unpredictable. They are not even considered, or even if they are considered, there is no contingency plan, there is no mitigation policy. There can be some purely technical difficulties because you cannot foresee them in advance. So there are certain technical difficulties which may come. People, humans, some may get ill, some may leave the job, there are so many things which can happen. Sometimes miscommunication. There is a hierarchy in the project team. So someone will say something, or miscommunication, the message is not being delivered, like this. Sometimes the project management or project manager, he does not recognize, he failed to recognize that the project schedule is not going up to the mark, or we are behind schedule. And then he doesn't do anything to correct this problem. No action has been taken. So these are the cause of failure. In the project scheduling, what are the basic concepts? The most important here is the aggressive or unrealistic deadlines. For example, 2 years it will take for work to be done, and you're just being told, okay, you have to do in 1 year, or say 1.5 years. So these are the fact of life in the software scenario, in the software field, in the software business. Unrealistic deadlines will be there because all is guided by market. Because if you don't give, the other may have the competitor may launch his product. So if the deadline is unrealistic, a competent project manager, as a competent project manager, what should you do? Protect your team from these schedule pressure, undue, unrealistic, and reflect the pressure back to the people who are the originators, who have created this pressure. So in case of unrealistic deadlines, what you're supposed to do? If you can't complete it, there are certain ways to mitigate. The first one is, all the historical data from the past projects, please use that to estimate the time, the effort, the duration, all these. Then determine the estimated effort and duration, as I just said, using the historical data or past projects. Then try giving an option of incremental process model, or use the incremental process model. That is, if you have, say, 50 functions to be given, choose the 20 basic functions and then give it. These are the critical functionality and these are imposed in the deadline, but others can be delayed further. and just document all the plan you have made. Then meet with the customer. Try to meet along with all the detailed estimate you have created. Explain why, in a very kind words, this deadline which is being imposed on us is really unrealistic, because all the estimates what you have done has to be very prominent, has to be realistic, and also that what kind of percentage improvement every increment you are going to give in order to achieve the deadline. That is, indicate the percentage improvement. Also offer the incremental development strategy as an alternative. So this you can do. Project scheduling. What happens here is that we need to find out the time or schedule when what work will be done. So in a technical project, the whole activity or whole process, you have process like the waterfall model or the spiral you choose. These processes are divided into activities. These activities are divided into tasks. So finally, you have to have many small tasks. The technical project, there can be many small tasks. For example, waterfall model. These different stages of the model. And these tasks which you have decided, some of them may lie outside the mainstream. That is, when you have decided these are the tasks, they may be completed without any worry, because they are not going to impact any kind of impact on the project completion date. They are outside the critical path actually. So these can be done. These are tasks to be separated out, but these I am showing they are outside the mainstream. But there are certain tasks which are on the critical path. This red line you see, red arrows, this is a critical path. What does it mean? If these critical path, the tasks which are lying on it, if they fall behind schedule, the completion date of project is put into jeopardy, or it will suffer. So as a project manager, what is your objective? Your objective is to define all the project tasks, whichever tasks are possible. First thing is this first, deciding what tasks are to be done. Then all these tasks, there will be some interdependency. They will be dependent on one another. So build a network of that. Build a picture presentation like that. Identify the task that is critical. You need to know and show the critical path. For example, in 50 tasks, 10 are critical. This will be the central line of the path. Then track their progress, and to ensure that delay is recognized every day, one day at a time. Okay. So controlling and tracking is as important as making the project schedule. In project scheduling, you must have a schedule to monitor and control project. As I mentioned, making a project schedule is very important, but monitoring and controlling is even more important. So let us see what is software project scheduling. This is an activity that distributes estimated effort across the planned project duration by allocating the effort to specific software engineering task. Okay, basically scheduling is timing. What work will be done when? So which task is going to completed when? This will be the timing being given. Every task will have a deadline. I'll just give you a hint here. See, this is the task starting in January, ending in mid-March. So this is a kind of task. This is a scheduling you have to do. And this is to be done for every task which you have finalized. Okay, depending upon the project. So for example, this eighth task is going till end, but it is starting just in the beginning of March. During the early stages of the project planning, you don't need to make it very microscopic. So a macroscopic schedule may be developed, because this will identify all the major process framework activities of your software engineering activities and the product functions to which they are applied. That is, what are the major framework activities that is the macroscopic schedule will be made. But as the project proceeds, as the project gets underway, each entry on the macroscopic schedule, which we just did in the early stages, this needs to be refined into more detailed schedule. That is, the activity, the task under activity have to be properly told this is the time. So specific software actions and tasks are to be identified and they need to be scheduled. So scheduling for software engineering projects can be in two ways. That is, the schedule is already given to you. That is, end date for the release of the system or the software has already been imposed or told or given to you, already been established irrevocably. You cannot say anything, you cannot argue for anything. Okay, it is irrevocable. And the second thing is, maybe you are given a choice. End date will be set by you as a software engineering organization. These are the two ways scheduling can be done. For any project scheduling technique or management activity, this project scheduling, it has certain basic principle. Every project manager has to understand and know what are these basic principles. The first one is compartmentalization, division of the work, properly modularizing the task. That is, the project must be compartmentalized or divided in the way of divide and conquer into a number of manageable activities and tasks. For example, a framework activity or the process, under this you will have activities, under this you will have tasks, under this you will have functions. Interdependency. There will be different tasks, they will have some interdependency. That is, some tasks they may be in sequence, other may be in parallel, some may be concurrent, some may want the product to be delivered to the another work product. That is, let me show you here. Now these are all the work tasks. So this is the schedule. In week 1, what time it will start, what time it is end. And all that which are working together, these are the parallel activities. Some are serially working. Okay. For example, if you see week 2, last 2 they are serial. And then this diamond shape is a milestone. Some activities cannot start or commence until work product produced by another is available to this activity. There are certain tasks, they may work independently. Now the time allocation. Now each task which you have decided must be allocated some number of work units, person days of effort, what time, what people. Okay, that means it must be assigned a start and the end date, completion date, that are a function of the interdependency. You have to keep in your mind interdependency, and whether the work is done in full-time basis or part-time basis. Because part-time time will take longer, full-time the time will be less. Effort validation. Now what happens is, how many people you have allocated for what time. So ensure that no more than the allocated number of people have been scheduled at any given time. For example, 2 people working for say 7 days and 3 people working for say 3 days. More effort has to be allocated to number of people that work. Define responsibility. Every single guy has to be given a responsibility and a schedule. That is, you are a specific team member, you need to do this task and this has to be completed in this time. Then you have to have a defined outcomes. Every task should give some outcome, should have defined outcome. What is the deliverable? What are the work products? That also comes under defined milestone. Every task should be associated with a project milestone. What is a milestone? The project milestone is when one or more work product or the output have been reviewed for the quality and has been approved by the seniors and the review team and the quality people. Then we say, okay, we got the milestone. The relationship between people and effort. Now, how many people are to be introduced, hired, or put into work, and what effort? Effort is basically people. It's all about people. It comes in person month. One person in 1 month, how much work he will do. So there is a common myth, which is prevailing, that if you are digging a hole, there are 4 people working for 4 days, make it 8. They will work in 2 days. Will it happen? In mathematics also, the result will be different. So this is there in software engineering also. If we fall behind schedule, we can always add more programmers and catch up later in the project. This is not true. That is, if you put more people, the work will be done in no time. This will have a disruptive effect on the project, because your schedule will slip even further. For example, these are new people. A person is guiding them, teaching them. So the new people has to learn. That will take time. The person who is actually working on the project right now, he will be a tutor. So he will not be working on the project. He is actually tutoring. So taught and tutor, all these, the project will suffer. And more people means more communication. Number of paths will increase. The complexity of communication will increase. And that will even more slip your schedules. So these are some inherent factors which are to be considered. Over the years, the different data, it may be empirical data or theoretical analysis, it has demonstrated that the project schedules are quite elastic. They are elastic. But not at the end of the project. That is, if you are given a time that this is the time you have to complete, it may be elastic. It is possible to compress a desired project completion date by additional resources to some extent. That is, you can compress it, adding some certain additional resources. It is also possible. I'm not saying that, if you are putting the effort or the programmers in the last phases, you will fall in trouble. I'm just saying, if you have a project schedule, you can stretch it, you can compress it. That is, it is also possible to extend a completion date. You can stretch it and you can combine it, but not at the end that, oh, this time nothing is working, put more people. Okay. The relationship between people and effort. Now this figure is very important. This is a Pnr curve. This stands for Putnam, Norden and Rayleigh curve. And this is giving an indication of the relationship between the effort, which is actually the cost also, effort applied on the y-axis, and on the x-axis you see the delivery time for the software project. So we need to see the graph, how it is shaping in terms of effort and the development time. The curve, what it is indicating? There is a minimum time t0 here, and this indicates a flat curve. This is the least cost of delivery. What I'm trying to suggest is the delivery time that will result in the least effort consumed. Least effort, this is the time t0. Now if you go to the left, that is to the y-axis or to the origin, that is, you want to accelerate the delivery, you want to compress the schedule, project schedule. The curve will rise non-linearly. You see the curve? It is going non-linear. This is the non-linear curve. If you want to decrease the time, you want to accelerate the delivery. This is quite straighter here. That is, I'm talking about T0. See, let us take an example. If you want to take compress the time, you want to complete it at TD. The effort will be ED. Now you see, a level of effort ED will be required to achieve a nominal delivery time TD that is optimal in terms of schedule and available resources. It seems to be okay. But although it is possible to accelerate the time delivery, you see the curve. It rises sharply. The effort has increased so much. So Pnr curve indicates project delivery time cannot be compressed much beyond this 0.75 TD, because beyond 0.75 TD I'm talking about the left hand side, going on the left hand side. This below this 0.7 or on the left of 0.75 TD, this is an impossible region. impossible zone, because at this time, if you want to compress and go on into the impossible region, the project moves into the impossible region, and this is full of failure. The risk of failure becomes very high. And there is one more relation, very steady. It is in between 0 and T0. So just add 0 plus T0 by 2, that is going to be TD. So TD will be equal to twice of TD. That is also a relation. The lowest cost delivery option, T0, is actually twice of this TD. What implication is here? The implication here is that delaying the project delivery, if the project delivery or project schedule can be stretched, the cost will be less. Now let me show another aspect of this graph. These are 4 parts I am showing. The left one is the impossible zone. That means it cannot be completed within a certain time. First one. This region is the overstaffed, completed fast but inefficient. This is the linear range. The efficient staffing, manpower trade-off with time is good. This is possible. The last one is understaffed, becomes also inefficient. If you have less staff, inefficient. Now the software equation which we already had discovered and learned, this is derived from the Pnr curve and demonstrate highly non-linear relationship between the time to complete and the human effort applied to the project. So this is a non-linear curve. It has various independent variables involved. The B and B, let me show you here. I showed you this software equation. Now B was the special skill factor, P was the productivity factor, time was in duration, the project duration, E is the effort in person month or person years. So now the number of delivered line of code, the source statement, L is related to the effort and development time by this equation. We already seen that. L equals P into E raised 1 by 3, T raised 4 by 3. Now L is the lines of code, effort. How they are related? Let us see one more. E, as I said, E is the development effort in person month. E always in this is the unit of E. P is the productivity parameter, and then we have this P is a specific value that reflects a variety of factors that lead to high quality software engineering work. This P may range from 2,000 to 12,000 depending on the type of the project you are undertaking, and T of course is the project duration in calendar month. Now let us rearrange it. A certain rearrangement, this effort E will give a very good equation. L raised 3 divided by P raised 3, T raised 4. So let me write it because we are going to use it in an example. So E is the effort spent in person year. Please remember person year, or the entire life cycle for the software development and the maintenance part also. And T is the development time in years. Please remember here in this equation the time will be in years. Now if you have the amount that is say $8,000 is paid per month to a person like this, you can also compute the cost. We have already done this in the previous discussions while we were doing the project estimation. But let me take an example of this particular equation. Just consider a complex real-time software project estimated at line of code as 33,000. The capital L is 33,000. The effort is 12% month of year. So let me just write it and put these values. I just want to show what is going on here. Effort is 12 and 33,000 is L, and we have to cube it, and P is 12,000 you are going to take here, and this time I am talking about. Okay, T to the power 4. So now, when you find out the time, there will be some time will come. Okay. Now, if I make this 12 as 8, what will be the time? The time will be 1.3 years. That is equivalent to 15.6 month. You can do this mathematics. Now, if we extend the end date to 1.75 years, that is T from 1.3, if I am changing it to 1.75 years, what will happen? This is a highly non-linear nature of the model. What it will give? Now, if I am stretching, I have to use P as 10,000. You can calculate. I'm just writing the equation now. The effort will be L is 33,000. P I am taking as 10,000 because we have stretched it. Change the time. 10,000. And time is 1.75 to the power 4. When you compute it, the effort in person years will come as 3.8. Now that means that if you extend it from 15.6 to 20.1 month, that is extended the end date by 6 months, we can reduce the number of people from 8 to 4. This is what the relationship between people and effort means. Effort distribution. Now, in a software development life cycle, there are different phases. So what phase will take what number of project estimation, project effort distribution? This we need to see. Generally accepted guidelines is like this. A recommended distribution of effort across the software project is referred like this: 40, 20, 40 rules. Let me reiterate. A recommendation distribution for software process is 40, 20, 40 rule. What does it mean? It means the first part, that is the front end part, that is the analysis and design part. Once you got the requirement, you have to do the requirement analysis, and the design part, that is going to take the 40% of the effort. The similar part, 40% will be given to the back end part, that is the testing and debugging part. Okay, coding will take around 20% of the effort, coding part, and this is 20-40, 20-40. And project planning, because it takes a less time, 2 to 3% of effort is acceptable. Customer communication and requirement analysis around 10 to 25%. See, these are the numbers. You can change it depending upon your project. So you can see the difference in the number which I am telling. Software design, 20 to 25% of effort. And this, just let me add this testing and debugging, it's around 30 to 40%. So what you see in this table in the above part, that is the actual value you need to remember. But basic thing is 40, 20, 40 rules is adopted. Defining a task set for the software project. This we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.